What's up, you freaking geniuses? So in this video, I'm going to teach you how to classify parallelograms in the coordinate plane. All right. So this first problem says, determine whether the parallelogram is a rhombus, rectangle, square, or none. All right. So before jumping into this, let's just make sure we understand the differences between a parallelogram, rhombus, rectangle, and square. So a parallelogram is basically just a slanted rectangle, right? So it looks something like that. Okay, and as you can see, we have two sets of congruent sides, right? So this side is congruent to this side, and this side is congruent to this side, right? They're also parallel, right? Those are two different sets of parallel lines. Okay, and lastly, the diagonals are different lengths. So this length, we could do a little bit better than that. This length right here is a different length than this length right here. Okay, so the diagonal lengths are not equal to each other. Now, if you compare that to just a regular rectangle, again, we have all these congruent sides, right? That is congruent to that, and these two are congruent as well. Now, in a rectangle, the diagonals are equal to each other. They are congruent. They're the same length. Okay, and with a rhombus, it's basically just a slanted square, right? So that means all the sides are the same length. Okay, but similarly to the rectangle, the diagonal lengths are different, okay? But with a square, right, if we draw a square, obviously all the sides are congruent, they're all the same length, but the other thing is all the diagonals, the two diagonals are the same length, okay? Similar to the rectangle, right? So the first thing that we're gonna do for this problem to figure out what type of shape we have here is to find the lengths of each side. Okay, so we have to find four different lengths. The length from I to C, the length or the distance from C to U, from U to P, and then lastly from I to P, right? So then there's four different lengths. And the way that we find lengths or distances in the coordinate plane is by the distance formula, right? So again, the distance between any 2 points is equal to the square root of x of 2 minus x of 1 squared, plus y of 2 minus y of 1 squared, all right? So let's first start by finding the distance from I to C. So the distance, and I'll just write it like this, I to C is equal to, again, this big old square root. So first we're going to subtract the x coordinates. So let's say -1 minus 0, right? So -1 minus 0. And we're going to put that in parentheses, and that's squared, plus, now we're going to subtract the y coordinates, right? So the y coordinate here is 2, so 2 minus 0, right? So 2 minus 0, and that's also squared. So here, this is going to be equal to the square root. Let's see, -1 minus 0 is just -1, and -1 squared is +1. Now here, 2 minus 0 is equal to 2, and 2 squared is equal to 4. 1 plus 4 is 5, so here we get the square root of 5. So the distance from I to C is equal to the square root of 5. Now we can leave it as the square root of 5 if you want, or if you want to find a decimal, you could plug that into your calculator, and you'll get that this is approximately 2.24. All right, so the distance from I to C is about 2.24. Now let's find the distance from C to U. So from C to U. So again, this is going to be equal to big old square root. And again, we're going to subtract the x coordinates first, so from C to U. So we're going to say 0 minus 4. So we're going to say 0 minus 4, and that's squared, plus, and now the y's, right? So we're going to say 0 minus 0, which obviously is just 0. All right, so then here, this is going to be equal to 0 minus 4 squared is equal to -4, and -4 squared is equal to 16. And then here, 0 squared is just equal to 0, right? So then this is equal to simply the square root of 16, which is equal to 4. Okay, now lastly, let's find the distance from U to P. And in this case, I'm just going to give you the last two. So we're going to find the distance from U to P, and then again, the last one would be from I to P, right? I to P. All right, so the distance from U to P, we're just going to say mathemagic happened here. And the answer for U to P is equal to the square root of 5. All right, and then for I to P, again, mathemagic happens, and this is equal to 4. Okay, great. So now we have our four lengths, right? So we got the square root of 5, 4, square root of 5, and 4. Okay, so as you can see, we got two different lengths, right? We got the square root of 5 and we got 4. So since all of these lengths are not the same, that means it's not a square and it's not a rhombus. So in this case, it would be either a parallelogram or a rectangle. Okay, so we've narrowed it down to a rectangle or a parallelogram. So now, in order to compare those two to figure out which one it is, all we have to do is find the diagonal lengths and compare those two. So to find the diagonal lengths now, we're going to go from I to U, and then we're going to go from C to P. All right. So the distance from I to U is going to be equal to, again, the distance formula. So subtract the x coordinates. So we're going to say -1 minus 4, right? So we're going to say -1 minus 4, and that's squared. And now let's subtract the y coordinates. So the y coordinates are 2 minus 0, which is just equal to 2, right? So we got 2 squared. So this is going to be equal to -1 minus 4 is -5, and -5 squared is 25. Then here, 2 squared is 4. So the distance from I to U is equal to the square root of 29. All right. Now the last distance we need, again, is just from C to P, right? So from C to P, and that's going to be equal to the square root of 0 minus 3, right? So we're going to say 0 minus 3, and we're going to add that to the y's, and the y's are 0 minus 2, right? So 0 minus 2. So then this is equal to 0 minus 3 is -3, and -3 squared is 9. Here, -2 squared is equal to +4. So the distance from C to P is equal to the square root of 13. Okay, so again, these are the distances for the diagonals. And as you can see, they are different lengths, right? They're different distances. So that means this is not a rectangle, right? Because again, in a rectangle, the two diagonals are equal to each other, but in just a regular old parallelogram, again, these diagonals are not equal to each other, right? So since we got different lengths here, that means this is just a regular parallelogram. Okay, and one last thing I want to point out is just speaking about the rhombus and square one more time. So again, when we found the 4 different lengths, if they were all the same length, or if they were all the same distances, that means it would have been a rhombus or a square, okay? And if it was, then again, we would have just checked the diagonals like we just did right here, and it would have been the same thing, right? So if the diagonals, if these were equal to each other, that means it would have been a square, because remember, for a square, the diagonals are equal to each other. But for a rhombus, which is just a slanted square, these diagonals are not equal to each other. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below.